This is AP Calculus AB. We're looking at free response question 2000 from the 2002 test, question 5, form B. Consider the differential equation. Let y equals f of x be a particular solution to the given differential equation for x between 1 and 5, such as the line y equals -2 is tangent to the graph. Just want to point out, y equals -2 is tangent. Y equals -2 is a horizontal line. Horizontal lines have a slope of 0. There is a ton of information packed in us knowing that. Find the x-coordinate of the point of tangency and determine whether f has a local maximum, minimum, or neither at this point. Justify your answer. So we got lots to do here. First of all, we are supposed to find, well, it says let y be a particular solution. We're supposed to find the x-coordinate of this point. So to do that, if we take the derivative, which is dy over dx, equals 3 minus x over y, we know what y is. It's -2. And at the same time, we know what dy over dx is. It's 0. Once again, y equals -2 is a horizontal tangent line. All horizontal lines have a slope of 0. So if we put the slope in at 0, and at that same instant, we know -2 is the y value. If we solve this, we're going to get that x is 3. So to sum up, the point of tangency is 3, -2, and at this particular time, dy over dx is 0, the slope. So the first part of the question was, find the x-coordinate of the point of tangency. So we just said that it was 3. I should probably write that out formally. The x-coordinate of the point of tangency is x equals 3. That answers one question. Second question, determine whether f has a local maximum, minimum, or neither at this point. Justify your answer. Well, we know for sure that at the point 3, -2, there's a horizontal tangent line. So the question is it a minimum or maximum? It's got to be one of the two. In order for us to figure out if this point of tangency, which has a slope of 0 at that point, if it's a minimum or maximum, we can do the second derivative test. So let's do that. So we knew that the first derivative was 3 minus x over y. To find the second derivative, we're going to have to use the quotient rule. Take the derivative of the top, which is -1 times the bottom, minus the top times the derivative of the bottom. You got to be careful. If we're taking the derivative with respect to x, the bottom is a y. It's the wrong variable, so we have to say dy over dx. I'm going to change that color from emphasis. Didn't mean to change that color. There we go. And then that's over the bottom squared. Simplifying this a little bit, and also knowing that dy over dx is this monster right here, we could say the second derivative with respect to x is a -y minus the difference of 3 and x times the difference of 3 and x over y. Because once again, I'm just replacing this with this, and then we have the bottom squared. We want to know, using the second derivative test, if we plug in the ordered pair 3, negative 2, is our answer going to be positive or negative? So let's evaluate this at 3, negative 2. So we're putting a negative 2 in for the y values, and the 3 in for the x values. We just want to know, is this thing positive or negative? A great thing happens here. We get 2 minus 3 minus 3 is 0. So that's the great thing that happens. On the bottom, a negative 2 squared is 4. So this ends up being 2 fourths. Well, 2 fourths is positive. So I have no room. I apologize. That means you also have no room. Conclusion we can draw from this is the second derivative is greater than 0 at 3, negative 2. Therefore, f of x is concave up. Therefore, 3, negative 2 is a relative minimum. For my class's purposes, I like to say that it's concave up. The AP test doesn't care if you say that. They just care if you go from the second derivative as positive to it being a relative minimum. As far as points go for this particular question will be worth 3 points. It's a pretty tough 3 points. You get 1 point if you figure out that x is 3. You get a point for coming to the conclusion it's a relative minimum, and then you get a point for justifying how you know it's a relative minimum. Cool? Cool. B. Let y equals g of x be a particular solution of the given differential equation with x being between negative 2 and 8, with the initial condition of 6, negative 4. Find g of x. Well, we were given that dy over dx is 3 minus x over y. We want to separate our variables and integrate. So this is going to be pretty straightforward, it looks like. Integrate both sides. On the left with respect to y, on the right with respect to x. If we add 1 to the exponent and multiply it by the reciprocal, I forgot my half. Add 1 to the exponent multiplied by the reciprocal. Then we take the initial condition, which is g of 6 is negative 4. Let's figure out what c is here. So I'm going to put a negative 4 in for y and a 6 in for x. I'm going to get half of 16 equals 18 minus half of 36. It's going to give me 8 is 18 minus 18. So therefore, c is 8. So then if I take and I replace the c in this general solution with 8, I want to get y by itself to figure out what the particular solution is. So we're going to multiply every term by 2. I'm going to square root both sides. Now when I square root both sides, I get plus or minus, which means This is not just a particular solution, it's two particular solutions. So the question you got to ask yourself each time, which equation contains the initial condition that we were given of 6, -4? Well, notice this y value is negative. For this y value to be negative, we got to choose the negative one. So our particular solution is g of x equals negative square root of 6x minus x squared plus 16. How do points work for this? Well, there's a ton of points in this one. You get 1 point for separating your variables. You get a point for integrating x correctly, a point for integrating y correctly, a point for evaluating at the initial condition, a point for getting c, and a point for getting the actual particular solution. All right, that concludes this problem.